Welcome back to Machine Learning Web Series. In my last video, I had explained briefly about data science and its sub-branches used in information technology industries. Today, I'll also explain how the techniques and concepts found in 4 branches of data science are used to evolve new branch of IT, famously known as machine learning. So let's recap with 4 elements of data science. That is 1. Statistical analysis, 2. Data mining and big data analytics, 3. Pattern recognition, 4. Artificial intelligence. Let's refresh and start with 1. Statistical analysis. Statistical analysis is a science of collecting, exploring and presenting large amounts of data to discover underlying patterns and trends. Statistics are applied every day in research, industry and government to become more scientific about decisions that they need to be made. Statistical analysis can be broken down into 4 discrete steps as follows. 1. Describe the nature of the data to be analyzed. 2. Explore the relation of the data to the underlying population. 3. Create a model to summarize understanding of how the data relates to the underlying population. 4. Prove or disprove the validity of the model. The goal of the statistical analysis is to identify trends. For example, researchers keep children healthy by using statistics to analyze data from the production of viral vaccines, which ensures consistency and safety. Coming to the second element, that is data mining and big data analytics. Data mining is the process used to extract usable data from large set of any raw data. Data analytics is the process of examining data sets in order to draw conclusions about the information they contain. If the data is huge and cannot be analyzed using regular software, then it is called big data, and its analysis is called big data analytics. Big data is the collection of huge amount of data that requires special database management systems to analyze and take out useful insights from it. It is the process of evaluating the unrecognized patterns in the sets of large raw data as per the different perspectives to categorize the data into useful information, resulting in gaining business insights to solve issues beforehand. Big data analytics is used by companies in data-driven decision making and to make business-friendly decisions. Coming to the third element, that is pattern recognition. Pattern recognition is the process of recognizing patterns by using machine learning algorithm. Pattern recognition can be defined as the classification of data based on knowledge already gained or on statistical information extracted from patterns and or their representation. One of the important aspects of pattern recognition is its application potential. Examples of pattern recognition are speech recognition, speaker identification, multimedia document recognition or MDR, automatic medical diagnosis, etc. Coming to the fourth element, artificial intelligence. Artificial intelligence is the ability of computer program or a machine to think and learn. It is also a field of study which tries to make computers smart. They work on their own without being encoded with commands. John McCarthy came up with the name artificial intelligence in 1955. AI can also be classified into strong artificial intelligence and weak artificial intelligence. Let's see how they differ under various parameters. Let's understand strong artificial intelligence. The system incepted to simulate human reasoning by artificial intelligence is called as strong AI. Building such a strong AI model is an Herculean task. Intense research is underway to make this happen, that is, to develop strong AI systems. Now let's understand weak AI, also known as narrow artificial intelligence. Weak AI is defined as the systems designed to accomplish a specific task. Designing such a system is relatively easy. There are systems which accomplish this functionality, but research is underway to create better narrow AI systems. In recent decades, technology has grown rapidly and massively. For every job lost to technology, there are many other new vacancies cropping up. If it had been the case where a new technology will take all our jobs, then majority of the world would have been jobless. but that's not the case. Lot more new data science and machine learning related jobs are getting created. Those working with AI today make it a priority to define the field of for the problems it will solve and the benefits the technology can have for the society. It's no longer a primary objective for most to get to AI that operates just like human brain, but to use its unique capabilities to enhance our world. Artificial intelligence will rise through its potential and goodwill and benefit the mankind in general. Now let's move to today's topics, types of machine learning techniques. As most of you know that there are four types of machine learning techniques, namely 1. Supervised machine learning, 2. Unsupervised machine learning, 3. Semi-supervised machine learning, 4. Reinforcement learning. These are the machine learning which has evolved into smart systems that is being used in everyday life. AI technology has evolved in leaps and bounds, and today we have self-driving cars and so many smart systems that have been imbibed into our daily life. So let's explore the machine learning types. Let's start with supervised learning. In supervised learning, the data set has known labels or output to identify patterns or similar characteristics of group data. In supervised learning, it would require training examples in the form of xi, yi, and I ranging from 1 to n, where yi are the true or correct actions must be taken in state xi. Supervised learning makes machine learn explicitly. In supervised learning, data with clearly defined output is given. In supervised learning, direct feedback is given. In supervised learning, model or algorithm predicts outcome or future value. Supervised learning is used in resolving classification and regression problems. Applications of supervised learning are 1. Risk evaluation, 2. Fraud detection, 3. Prediction of financial results, 4. Recognition of image objects during image analysis. Now let's understand unsupervised learning. In unsupervised learning, label or output are unknown. Unsupervised learning focuses on finding patterns and gaining insight from the data. In unsupervised learning, machine understands data, identifies patterns or structures. Unsupervised learning evaluation of data set is qualitative or indirect. Unsupervised learning does not predict to or find anything specific. Unsupervised learning applications are used in item categorization, clustering, customers, identity management, similar item recommendation, and association rule mining. Now let's see the third type of machine learning, that is semi-supervised learning. Semi-supervised learning has a small subset of input data which is labeled or output is known. Semi-supervised learning is a blend of supervised and unsupervised learning. Semi-supervised learning training data includes a few desired outputs or labels to do classification or clustering or prediction. Semi-supervised learning is used for situations in which the output is labeled and known for some subset of the input but not for all of it. Applications of semi-supervised learning is in spam email filtering, speech analysis, web content classification, medical predictions, because medical tests or expert diagnosis are expensive to conduct for a large set of unknown data. Now the last machine learning type, that is reinforcement learning. Reinforcement learning is mainly focused on making decisions based on previous experience or state. Reinforcement learning, new state and action is generated by the agent based on the policy of maximum rewards. This policy making is dependent from the feedback from the environment. Reinforcement learning is reward based learning. Reinforcement learning learns from positive and negative reinforcement. Reinforcement learning implies machine to learn how to act in a certain environment. Reinforcement learning aim is to maximize rewards. In reinforcement learning, intelligent agent learns to act in a certain environment based on maximizing rewards. Reinforcement learning aim is to optimize goals and finally win the game. Applications of reinforcement learning algorithms is in robotics, planning, computer-based board games, and self-driving cars. Coming to the common and popular algorithms of machine learning. Let's start with supervised machine learning algorithms, namely linear regression, lasso regression, logistic regression, regression, random forest decision tree, gradient boosting decision tree, neural networks, scalable vector machines, naive Bayes, k nearest neighbors, Gaussian process. The unsupervised machine learning algorithms are a priori rules, k-means clustering, main shift clustering, spectral clustering, kernel density estimation, non-negative matrix factorization, kernel principal component analysis, sparse component analysis, singular value decomposition, SOM, etc. In semi-supervised machine learning algorithms are expectation maximized algorithm, that is EM algorithm, a transductive support vector machine algorithm, that is TSVM algorithm, manifold regularization, autoencoders, etc. The reinforcement learning algorithms are associative reinforcement learning algorithms, actor critic algorithm, temporal differences reinforcement learning, Q learning, Diana, real-time dynamic programming, SARSA reinforcement learning, least squares algorithm for temporal differences learning, least squares policy iterations, prioritized sweeping algorithm, party game algorithm, sparse sampling algorithm, trajectory tree algorithm, policy search algorithms, policy gradient algorithms. I hope you got an overview of different machine learning techniques used for automation. In my next video, I'll be explaining the first of the 4 machine learning types, that is supervised machine learning, in detail. Please share your comments as it inspires me to do the further topics of machine learning. Please share this video with your friends and colleagues, and I will publish my next video, supervised learning, very soon. Till then, have a nice time watching my videos. Bye.